Right, I guess I'm live. Yep, I think I'm live. Okay. Right. So, guys, first of all, let's discuss what one hot encoding is. So, remember in the previous video, we had a ocean proximity column and there were some categories into it. And I told you that we have to drop first or last column or at least one column from it. And why is it so? Let's take a look. So, first of all, one hot encoding means one hot feature only. So let's say I have a gender category, and in that gender, there are two. I'm just keeping two for simplicity, male and female. And let's add one more, others. All right. So now my point is, take a look. This is a matrix of three columns and four rows. The first row corresponds to the category male. So wherever I have male, I would say it's one right here. And female 0, others 0, right? The second category is female. So the male column is 0, female column is 1, and others column is 0. The third category is again male. So the vector goes 1, 0, 0. You see? So the fourth category is other. So the mathematical vector for other becomes 0, 0, 1. So now what I've done basically is I've taken a category and I've converted that category into a vector form. Vector meaning that I've just converted into an array. So in a mathematical representation, I've created it. And why am I going after mathematical representation so much? Is because let's say if I have a vector of 0, 1, 0, 0, 1, 0, you can read it as female, right? This vector is female. Now the point is, I cannot make it 0, 0, 0. One of the categories should be there, should be present. You can't have a 0, 0, 0 vector. You can't have a 1, 1, 0 vector. Saying you can't be male and female at the both at the same time, right? So my point is, there is only one hot feature. It could be either in this form, it could be either in this form, or it could be either in this form. You can't have more than one basically hot features over here. So why is that so? Let's take a look. In usually, if we, I'm not gonna go into much of the statistical analysis. Just I'm gonna go to some intuition. Like let's say I have a linear regression equation, not linear regression, but let's take a linear regression equation of, and simply I will say a0 x0 plus a1 x1 plus a2 x2, where x0, x1 and x2 are some features and a0, a1 and a2 are some coefficients. Just like we previously had y equals mx plus c, where x was, if you remember, work experience and y was, if you remember, salary, right? M and C were trainable parameters. Remember? In the first linear regression lecture, we discussed that. So, in that same way, instead of having work experience, now let's say I'm talking about work experience, number of projects, number of holidays someone has taken, number of holidays someone has taken. So, these are the three determiners of having some kind of salary, right? So, now these A0, A1, A2, just like MC, they become coefficients. Like how strongly does work experience affect salary? That is determined by A0. How strongly does projects determine salary? That that is determined by the coefficient A1 and so on. Now my point is, usually in statistical analysis, what we do is we say something like this. If I increase x naught by 1 unit, how much of that increase of 1 unit affects my salary, right? Let's say if I take one more holiday, How much does that impact into my salary? So now the point being, x0, x0, x1 and x2 are three independent columns, are three independent features. You can change x0 and it won't affect x1 and x2. But in the case of categories where you have one hot features like 100, let's assume this is male. This is the male category and the one hot feature goes 100. You can't have something like this. Let's make it a 0 and then calculate its impact on the dependent variable. Dependent variable meaning in this case it would be something like, let's check out. In this case, do we have even a no? In this case, we are not having a dependent variable. We will discuss more about it in the later sections of the additional tutorials. Let me show you. So in the later sections of additional tutorials, I have embedding vectors. So over there, we will discuss more about like one hot vectors, what are, and basically how a string is converted into a vector of different form. So this is a vector, and basically a lot of things we will discuss over there only. Let me see if I have a simple example over here. This is not run, so I would have to run it. Okay. Anyway, when we come to the embedding vectors topic, then we will discuss more. So at the moment, I hope you have a faint bit of idea about one hot encoder. Secondly, the point that we were discussing was that in one hot feature array, we cannot change one feature and check its impact on the dependent column. Because as soon as I change this one, another category will take a one. I mean, take a look. Let's assume x0, x1, and x2 are one hot features. And one hot features are something like this 0, 0, and 1. If I make it a 0, I necessarily have to make other thing a 1. You see, the point is my three of the columns are not independent at the moment. If I change one, it impacts the other. So I cannot confidently say if I change, let's say, the first column, I can calculate the impact on the dependent variable. We cannot do that. More examples we will follow later. But the point is, whenever we do one hot encode, we try to either drop the first column or drop any of the other column. In scikit-learn, there is drop first, drop last. In pandas as well, where when we do pd.get dummies, we have the option to drop first column and the last column as well. And that makes sense really, because if you drop first column, the category becomes something like this. You can make it 0, 0, you can make it 1, 0, you can make it 0, 1 without having any kind of correlation between these two. So let's go back to today's topic, which is classification. And first of all, launch labs, easy as it is. Docker containers, open code server. Yes, you see, this is like very easy. Even I am, as a founder, I'm very excited about it. Not much as a developer, but as a as just a person who loves coding. This is so easy. Anyway, we are going to look at the classification today and what classification actually is. Let's first basically discuss that regression was nothing but predicting numbers. So in the regression part, what we had was some dependent variables and one target variable. That target variable was numeric in nature. Remember house price? We had a lot of features like number of bedrooms, number of people in town, and so on. We had features, and we were using those features to predict a numerical entity. That numerical entity being price. It could have been any other numerical entity as well. But in classification, what we will do is we will have some sort of features, and what we will predict is a category. Is it a category yes or is it a category no? Basically, in the backend, what will be happening is that a regression model will be activating. But let's say a regression model would be getting activated, and that regression model predicts a number like, let's say, for example, 5. It doesn't really mean anything at the moment, right? So we pass this number 5 to a function called sigmoid, and that sigmoid functions look like something like this. I know I'm not making a lot of sense at the moment. Just stick with me. That sigmoid function would be something like this. The point being that the sigmoid function that we have over here, it's going from 0, and sigmoid is this, right? Negative. Oh no, actually sigmoid is this. That was tanh that I by mistakenly created. So this is sigmoid. Its range is from 0 to 1. So now my point is, it will take the number 5 and it will convert it into a number between 0 to 1. Let's say the 5 is being converted into a number of 0.4. Then I can confidently say that 0.4 is 40% probability. What I mean to say is, in classification, we try to predict a category of yes or no. Two categories we predict using a simple function called sigmoid. We will take a look more when we go into the hands-on what sigmoid is and how we use it, and especially in deep learning what sigmoid is, we will talk more over there. So now my point is, basically the sigmoid function predicts for you the probability of being a yes. So the probability could be 0.1, 10%, 0.2, 20%, 0.9, 90%. So if we have a probability, let's say greater than 0.5, I can call it a yes. I am more than 50% sure that the category is predicted to be yes. It's supposed to be yes. So therefore the conversion. So first of all, let's take a look. We first of all predict a numerical value, a numerical number, which could be x or y or could be x1. Let's say for it's alpha, then the alpha gets converted into a probability. Like what are the chances that this probability belongs to the category yes? Then depending on if it is 0.1, 2, 9, 5, like whatever the probability comes out, like if the probability is more than 50%, we say yes. If the probability is less than 50%, we would say no. So classification is nothing but a form of regression only. And the basic form of regression that we use for classification is log regression. And we call it logistic regression, meaning that we take a log function of the regression. Basically, there's a log in the entire equation. I'm not going to go into the equation at all. It's a very simplistic equation, but right now this whole course is not for the technicals. It's not for the people who are from math background. This is just for the people who are likely founders like me, who are likely from economics background or from non-tech background. So this video is for them, like how you can also do AI ML without having to understand mathematics. That's the whole point. So let's come back to today's topic, and today's topic is classification. So we have a data set over here. So we have the telecom churn dataset. In this, we have customer ID column, which is not a good, which is not predictor really. Customer ID is unique for every customer, so we will drop it later on. Gender, we have male and female, so we will be doing the one hot encoding for it. Senior citizen is already having a one hot encoded part. 0 means no, 1 means yes. And partner dependents, we will do have to do one hot encoding for it, and so on. We have how many numerical features? Then tenure we have as numerical feature, and some missing features there are. And see, by the way, when you have a lot of columns, now pandas hide those columns by default for you. So if you want to look at all the features, then you just have to go to Google and say something like this. Pandas display more columns. I already have the prompt. So over at the Stack Overflow, I believe I will find it. Yep, right here are these options. I will just copy and paste them. import pandas as PD, maximum rows displays to be 500, maximum columns to be 500, and the width to be 1000 of a particular cell. So take a look now. I can see all the columns, and there are only three numerical columns as I found. First is tenure, and what else? Monthly charges and total charges. So the point is, we're going to use all of these as predictors. We're going to use all of these as features, attributes. You can say attributes of the data, features of the data, to predict if a customer will churn or not. This is a historical past data that we have been given. We're going to use this data to train a model, train a mathematical equation in a way that when the future data set comes in, or when the future data or future customer comes in, we will be able to identify a probability of this particular customer churning out or not. All right. Okay. So let's check out if we have some missing values or not. I believe we don't. And basically, one more problem we have in this data set is that it's a very imbalanced data set because only one third of the people have the category yes, and more people have the category no. And so why does that impact your model? Is let's understand that first before moving on to the classification topic. Like, let's say I have a data, ordinal target data of 000, 000, 000, and 1, meaning 9 of my customers have not churned, only 1 have churned. 9 of my customers have the target no, only 1 of my customers have target yes. This is the historical data, let's assume. And my predictions are only zeros. Like all of them are zeros. My model is blindly saying that every customer that comes in the bank or wherever, they are not going to churn. The answer is simply no. Even in this case, you see, coincidentally, it happened that 9 of the points were classified right, just out of mistake, you can say. So the accuracy is coming out to be 90%. But is this model even any kind of good? No, because my model made random predictions of zeros. At the moment, all my model is saying is whatever customer comes in, predict that category as a no. It doesn't make sense. It doesn't even have any kind of intelligence to it. Yet the accuracy is very high, 90%. So my point is, we need to have a balanced data set to train the model at least. So in here, I have 5 zeros and 5 ones, meaning I have 5 no customers, 5 yes customers. So if I at the moment say that all of my predictions are zero, all of my predictions are no, then my accuracy would be 50% because only 5 of these observations are right. Coincidentally, 50% is also coming, but I know at least that 50% is way less than my target 100%. I'm targeting highest accuracy and I'm only achieving 50%. 50% we can achieve by a hit and miss as well, right? So that's what is going on. So the point is, this is why we need a balanced data set. And to create a balanced data set, we will look at some techniques. But first of all, we will look at some distributions. When you open this notebooks, take a look at this kind of data and understand the kind of distribution that we have. Like let's say, depending on the tenure, do we have a relation of tenure versus churn? This is a box plot. So in the box plot, it says in the tenure, in the no category, the box plot starts from 0, goes on till 72-ish, 71-ish, where the median value is 38-ish. And the 25th percentile is 15, 75th percentile is 61-ish, and so on. For the years, this same data has a range of the same thing, like starting from almost 0 to 70. There are some outliers at the 70 part, but most of the data has low tenure amount, right? Okay, so let's check the correlation matrix. So the maximum correlation is 1 for, like, let's say senior citizen is 100% correlation with the senior citizen, which makes sense. Like one variable is correlated 100% to itself. But other than that, other than the values that are overhead diagonals, we are facing maximum of 0.4 correlation, which is like okay, okay-ish. it works. So then what we are saying is let's take a look at what this thing is. I would have to run all the cells above. So let's take a look at this churn datasets total charge column. Churn dataset total charges column, and basically it's a numeric column. And if I were to ask, like, the data type is object. Oh, see, take a look. One more thing I just noticed is it's a numeric column, yet the data type is object. So we have something bad in here. Something we are missing with this column. Something is wrong with this column. This column data type should be either a float. I mean, not integer, it could be, but it should have been a float. So what we are doing is we are usually I would have done something like this. It's pd.to numeric errors equals codes. I don't know what this code is doing. What I want to do is I want to change the data type. So I would convert it something like this. Dot lambda, no, sorry, dot apply. Apply to all the rows. What else? Lambda x. Try to create float of x. Let's see what the error is. It's saying that somewhere along the line I have an empty string. So that empty string is not being recognized as a missing value. But you cannot have an empty string and call it a float. You cannot. Like, let's say if I am to regenerate the same error, it would be saying something like this. Convert the float of an empty string. See, it's the same error. Now, what I will do is I will say try to convert. I will just create a function of clean function, like let's say clean empty string, and what it does is it takes some value, and all it does is basically it tries to convert this thing, uh, like let's say it tries this kind of code. So it takes the value and tries to convert that particular value into a float. If it happens, good enough. Except if it doesn't happen, if there is an empty string really, then what do you do is x, just say x equals np dot nan. Just insert a missing value over there, right? And let me explain again. So what I'm doing is with the try and except block, I'm saying try to convert the value into a float. If it happens, good enough, store it as X. If it doesn't happen, if it by any chance throws any kind of error, then go to the except block. Don't execute the try block. Go to the except block directly and take a missing value, replace that missing value, fill that missing value with that empty string. And at the last of the code, return to me the X variable. Now that I have created a custom function, what I'll do is I will say lambda x. What do you do? Clean empty string of x. Now take a look. Now what's going on is it has converted for me all the values to an an. Hmm. So now the try block isn't even working anymore. Okay. All right. So what else have we done incorrectly? I'm showing these in real time. See, I don't want to give you this code and show you like use the code and just run it because you are expected to have errors. That's why I'm live doing these things with you. So now my point is, first of all, let's check if our clean empty string function is even working or not. So I'm saying clean empty string, and let's give it a empty string really. So it's giving me a nan. If I pass 123 space, it's giving me a nan. So what if, I'm saying what if I have a structure like this, 123 and a space in there. So now what I will do is use regexes. I don't know if we have like done regexes, but the basic of the regexes would be something like this: that import re. It's very useful. It's very useful. Regexes are a very useful tool. When I was working as a freelancer for a company in which I had to do a lot of data cleaning, so I was using regexes most of the time over there. Let it be for any kind of data, even if I have to make a website or really anything, you have to clean the data first, and that was the hardest part. Not hardest, but the most time consuming part. So anyway, I'm saying re dot find all. Oh, let's do this. So I'm saying that total, take the total charges, apply over it. Re dot find all is a function. What do I want to find? I want to find everything inside X. And what's the pattern that I want to find? I want to find a pattern of any kind of numbers 0 to 9. Let's see really what it does. Name error, it's saying me re is not defined. So have I not like, executed the cell? Okay, executed the cell now. Okay, so what I'm doing is re dot find all the numbers 0 from 0 to 9 in X really. So it's not able to find any kind of numbers. Why is that so? So at the moment, I can say that something is very bad with this a particular string. Something is very wrong. Like let's say, I mean, I could have solved it using ChatGPT, but the whole point is to tell you, okay, like whole point is to tell you how to go about the errors. You don't, I mean, if you're getting an error, it's a good thing that you are having one chance to improve yourself. So anyway, let me see. Let's pull out one particular entity from it. It's 29.85 and looks like a string value to me. Okay. So if I pass in this thing inside re dot find all, let's see what happens. I'm saying re dot find all. Find all. What do I have to find? Acha, all right, I see. The first thing is the pattern, really. I dot find all the patterns. And second is where to find that pattern. Yep. See? Okay, let me insert a decimal point as well inside the finder. So, okay, re dot find all, everything. Have I found all? Yep. I have find all sort of decimal numbers, really. Now what else? What else I can do to convert it into a float value? So instead of using re dot find all, really, let's do something like this. Re dot substitute wherever you find this kind of a pattern, wherever you find a white space, replace it with nothing really. Find a white space. Let's first of all let me use wherever you find a white space, replace that with four hyphens. And where do you do? This is a string. Let's take its output. So wherever there was a white space, it has replaced the white space with four hyphens, right? So now I will use the same logic to basically get rid of that anything really, like anything that is not a decimal or a number. That would be my logic. So I will say re.sub anything that is not anything. I believe anything that is not. Uh, I believe that is the line. Anything that is not a 0 to 9 plus. Plus means in continuation. If you put 0 to 9, it will just literally search for 0 to 9 character as a character. but 0 to 9 plus means in continuation. We will more talk more about regexes later on when we are dealing with natural language processing. Wherever you have a pattern of 0 to 9 not, meaning wherever you don't have a 0 to 9 not, convert that pattern to basically 4 hyphen, and where to find that pattern X. So what's going on is, all right, how do I say not? Not in regexes, not in regex. I'm just checking Google search. Oh, this is what was happening. I was putting this outside the bracket. See, we all forget these kind of things. So anything that is not a 0 to 9, including decimal or anything really, just convert it into a hyphen. Now I will insert anything that is not a 0 to 9 and a white space. So convert it, and a decimal, sorry. I want to include a decimal as well. Anything that is not a 0 to 9, basically wherever you see a 0 to 9 and a decimal point, keep it same. And wherever, wherever you don't like, let's say what I mean to say is, wherever you don't see this pattern, introduce 4 hyphens for it. But I don't want 4 hyphens really. I want an empty string. So let's take a look now. Now that I've converted this entire thing, now can I convert it into a float? Because I have removed the empty string. I have removed wherever the empty string or wherever the special character was. Now I'm going to put it inside the float function. So float of this thing, will it work? Now it's saying that I cannot convert a float of empty string. So now basically what I will do is, now I will apply that clean empty string function. And now I have a, okay, try and accept. It's taking a lot of time for me to sort this out. Wow. Okay, let me go on. Let's just clean empty string, and I pass X to it. Let's see. It is giving me all the missing values because it's not even able to convert anything. So if I put float in here, if I put this inside float function, what does it output really? It's working so far. So why does it not work over here? Ah, see, I have a value over here and I'm putting values over here. That's why. Should I have given all right. So now that I'm using clean empty string function, I hope you have discovered this error very soon. But if you haven't, don't be confused. It was just a spelling mistake over here. Anyway, this sort of logic works. Like in this case, it was a very easy error. I thought it was a very confusing error. So uh, I was like, why is it not working? Because I've dealt with so many unclean strings now. Like there will be strings you will see like in the form of something like this, something like this. There would be things like this, and you would have to like str1, you would have to clean, and you would have to extract only digits out of it. And the way to extract digit out of it would be like either you substitute, either you find all. Usually I find all the strings like this. Find for me all the pattern that starts from 0 to 9. And where do I find the pattern? I find the pattern in str1. And see in the it's capturing for me all the characters as numerics. Characters are being captured. But if I want the characters in continuation, I would add if there is one or more pattern in continuation. That is the plus sign. So now 3 4 5 4 3 5 in continuation. You give me this thing. And let's say let's insert little more numerics over here. So now if I run this, so I have two of these things now. So After that, I can say join these two things up with a decimal. Decimal dot join this entire thing. So now I've created a string with I've like taken the same corrupt string, corrupt data, and converted it into a float value. And now that I have done this, all I need to do later on is to convert it into a float. I don't need a try block because I know that at this moment it will be converted into a float. See, now it is converted into a float. So I mean, this was a very simplistic case. So that's the total charges column. Later on, we will fill the missing value with a median. We could have very well used a simple imputer over here as well. So let's see how to do the missing value imputation with a simple what's to say simple imputer. Let me search for Google about it. Sklearn impute, and there should be sklearn.impute. Simple imputer, yes, it is simple imputer. Rest of the things I know because Sklearn API is very easy to figure out. Copy and all right. So I have float and I must have some missing values over here. So what I'll do is I will say from sklearn dot impute import simple imputer. I will say imp equals sim. Let me remove this. It's making it hard to type. All right. So simple imputer, create an instance out of it. And basically, what do you want to impute it with? I need to check that as well now. Like strategy. What's the strategy? Simple imputer. What's the strategy? So missing values are np.n. Strategy equals mean. And what are the other strategies that I could fill it with? Mean, median, mode should be there. But in numerical columns, mode doesn't really make sense. Most frequent value wouldn't make sense in a numerical column, right? So what am I searching for is mean, median. I'm searching for median. So okay, all right. So I'm saying strategy equals median. Let's see if it is working or not. Yep, it's working. So I will say m dot fit. Take a look at my data. And my data is this thing. Emp dot fit this thing. Not working. Expected a 2D array, got 1D instead. Oh, how do I convert it into a 2D again? By using two brackets? I don't remember. Yep, by using two brackets. I've just created the series into a data frame. Computer.fit, take a look at the data, calculate its median, and then imp.transform for me the same particular column. Again, the same error, meaning that I need a 2D array instead of 1D. So over here, I have the transformed array. This is how the simple imputer works. But if you want a easy manual way of doing things, then you can just say churn total charges, fill the NA with its median, and then replace whatever the output is with the original column. Then we are dropping out the customer ID column. And then we are saying in the churn, map the yes to 1, no to 0. Get dummies, do the one hot encoding for churn. And then we are training some models of logistic regression, decision tree classifier, random forest classifier, gradient boosting classifier. And see, all the APIs are very same, right? Like you have an import statement, then you instantiate, then you dot fit, then you dot predict, and then you calculate some kind of accuracy score, right? Then I'm just taking out as many models as I can and calculating like what's the highest accuracy achieved. Highest accuracy is achieved by logistic regression. But then again, what did I tell you? I told you that accuracy is not a good measure of calculating a classification task. Why? Because our data is heavily imbalanced. Remember the customer who have yes are one third the customers of who have churned no. So my point being, even in this case, my 82 accuracy could have very well been hypothetical or hit and trial. So I will try to check it out first of all with a classification matrix. Like let's say I know for now that logistic regression is giving me highest accuracy. Okay, so logistic regressions variable was, let me see, logistic regression variable should be starting with log something. Uh, I need to delete some cells. Okay, this is where I was. Type error. What is it? So many errors. Let me refresh the notebook entirely. See what whenever the point of using GitHub and this VS Code is that whenever you make a mistake, which you can simply revert all the mistakes by saying discard all the changes. Let me zoom in a bit so that you are also able to see. So I have at the moment changed three files and I want to restore the three files as to how they were in the previous checkpoint, in the previous saved state. So I will say like, okay, let's just discard all the changes. Sure you want to discard? Yes, I am sure I want to discard all the changes. And now my file would be completely new. Yeah, all right. Okay, so now that I have a completely new file, I was searching for logistic regression. So I'm saying run all the cells above and then give me something like logistic model, log model, log accuracy is there, log predictions are there. Okay, okay, so far so good. I don't want to type, that's why I'm just copying and pasting the code. So I'm saying accuracy score, not accuracy score, but rather I will print out classification report. I need to import it as well. Otherwise, another error will come up. From sklearn.metrics module, import classification metrics or classification report. All right. Then print the classification report. And basically, right now I'm printing the SVM predictions. And take a look. I told you that, see, SVM is giving me 74% accuracy. But the point is, just like I told you, in the zero class, in the no class, it's having precision, recall. These things are important. I will discuss it really, but in a while. Precision means basically out of all the predictions, how many predictions of mine are correct. Recall means that out of all the actual values, how many were we able to identify as correct? F1 score is really a mixture of precision and recall, basically a mean, but it's not arithmetic mean. It's not geometric mean. It's harmonic mean of precision and recall. Support means how many instances you are taking to calculate the particular matrix, how many rows you have taken to calculate it. So anyway, take a look at the class one. We have precision zero, meaning out of all the predicted values, we have made zero correct predictions. Recall is zero, meaning that out of all the actual ones, we have been able to identify no nothing. We weren't able to identify any single one. Often score, then again is 0. And see, this error basically means that undefined matrix, meaning that have no prediction in the one class. So whatever accuracy we have, 74, it came out by a mistake. And now let's check it out, how the logistic model is working. Logistic regression is somehow working fine. Wow, I didn't expect to run sort of this code. Let me run it all. Wow, logistic regression is actually working good, 63% good in the class 1. See, there are two classes, right? The class of no and the class of 1. And the total accuracy is 82. So, okay. Now the point is, I told you I need to, oh, I'm getting another error. Ah, you would be getting the same error as well. Module not found. Basically I have chosen to not pre-install just some modules so that you would know how to install these modules later on. So I'm saying pip Python manager install minus u. I don't know what that means. Imbalanced run is the package name. So pip install this thing. Now that you have installed it, it would work. And basically, if you're getting, even after installing, if you're getting the import error, no, that just means that you have to restart the entire thing, because sometimes it takes a restart for the entire package to work. I'm restarting and run all. This video has been stretched for long, right? Because of the errors. I know, but okay. It's taking quite some time to train. Oh yeah, it's going on. It's running. So now what I'm doing is doing the entire thing all over again, but this time from IMB learn, I'm importing SMOTE. SMOTE means synthetic oversampling of minority data. Let's check it out. SMOTE, synthetic minority oversampling technique, meaning that it will try to balance the data. Wherever the minority class is, it will boost the minority class up to the majority class so that we have a balanced data set. And we will do all the pre-processing that we have done. Remove the customer ID, and this code is for converting your total charges column, that headache, to float. And then I'm segregating the data into X and Y. Then I'm taking Y, mapping the Y into 0 and 1. Then I'm saying these are the categorical columns. Dot columns means that get me only the column names. Then I'm saying let's create a numerical pipeline. Then I'm saying let's create a categorical pipeline. In the numerical pipeline, just use median as a strategy. In the categorical pipeline, use mode. Mode means most frequent value. And then use the one hot encoder with drop first category. And handle unknown ignore means that if you see unknown category in the test data, I just ignore it. As simple as that. And then I'm saying the entire preprocessor becomes something like this. Column transformer, use the numerical pipeline on the numerical columns, use the categorical pipeline on the categorical columns. Then we have the IMB pipeline. So IMB pipeline says, like, take the preprocessor for your column transformation, then apply SMOTE to it, then you use the particular model, right? So instead of using scikit-learn pipeline, in here I'm using IMB pipeline, IMB learns pipeline. Now I'm doing the train test split. Then again, I have some model double dunders, and these are the parameter names of an estimators, max depth, minimum sample split, and so on. And the rest of the code is simple, like randomize search CV, use the pipeline. Pipeline could have been from scikit-learn, from the IMB learn, same thing really. Then these are the parameter distributions, number of iterations, cross validations, scoring. Base your scoring on accuracy. And see, whenever uh, If there was an imbalanced data set, now I would rather score my entire thing using recall rather than accuracy. But right now, accuracy is fine because at this moment, IMB Learn has balanced the data set. Then dot fit, dot predict, and here we go. Accuracy is coming out to be 79, which is lesser than before, but or at least our F1 score is better now for the class 1. But I believe a simple logistic regression was working better than this for some reason. Let's take a look at confusion matrix and let's calculate some precision and recall things over here. Accuracy means 901 plus 217 divided by all four sums. So if I were to take this entire thing, I could say something like confusion matrix normalize equals to, oh, normalize doesn't work. Why? Oh, true. Okay. Okay, let's not go there. Another error is coming up. I don't want to waste a lot of your time, both of your time basically. So over here we have the confusion matrix. Let's understand the confusion matrix in the next video because this video has been stretched out for quite a long time. 1 hour really, almost an hour. The basic would be that you have the actual values over here. There were actually 901 people who have no churn and are predicted to have no churn. There are 157 categories where there were people who churned, but I predicted them as no churn. There are 134 people who have the category no churn, and I have mistakenly predicted them as churn. And there are 217 people who have churned, and I have predicted them as churned. So this is true positive in a lingo. This is true negative, and this is true positive. So and these two cells 134 and 157 are the errors. And 134 says something like this that I'm predicting these 134s as people who would churn, but they haven't. In the test set, they haven't, but my model did predict them as churned. So we will understand confusion matrix in the next video by taking a very simple example. And the simple example would be this one. Or let's just finish it over here only. I'm taking this entire data, copying it, and going to ChatGPT to paste it because I don't want to type entire thing on my own. So take a look. It's a day in the day of ChatGPT. Why should I write the code manually myself? So I'm saying make a confusion matrix plot. Come on, look. All right, it made it. So the point is that in the data itself, we have nine zeros and only one single one. But my model is predicting everything as a zero. So at the moment, every prediction is zero, meaning that yeah, meaning that if I am to take a look at this number nine says actually there are nine zeros, and I predicted all of the nine as a zero, which is fine. Okay. Then I have zero number of ones, which I predicted as ones, zero, right? Then I have zero number of zeros, which I predicted as ones. Okay. So the entire thing really is there are zero predictions for the category one. So now let's ask it Give me the code. Give me a sklearn code for it. Yep, this is the code. I remember. And all right, let's plot it. Yep, it has made some weird arrows, but okay. All right. So take a look 9010. And in this case, my recall would be out of my recall would be. Do I have a recall over here? No, but I believe I have. Let's also print alongside it the classification matrix. Oh, right here. Okay. Target data, white true. This is the white true, and this is white red. All right. So now let's take a look. I am making zero predictions for the class one. So class one is very, I would say, problematic for us because our model is not even predicting a single instance of class one. All right. So the recall in this case is out of all the actual zeros, how many were we able to identify as zeros? All of the nine are being identified as zeros. So recall is 100% for the class zero. Okay. And now let's check the precision for class zero. Precision says out of all the predictions that I have made over here, how many were correct? Only nine are correct, right? So 90% is the precision. And F1 score is the harmonic mean of precision and recall. And support 9 means that we have 9 examples for the class 0, one example for the class 1. Precision for class 0 is actually it's not 0, it should be undefined because we are not making any prediction on the class 1, and the definition goes something like this, like out of all the predictions made on the class 1, how many were actually correct? I'm not making a single predictions. So this should have been that's why the error as well that we are having over here. So that's about it. Let's not confuse you further and close this video. And if you want more, you could always go to YouTube and search for these things. Although with practice, really, you would be able to understand. So we will be doing a lot of projects, and with practice, you would be understanding more about how to read, recall, how to understand precision, and what exactly support means, and why exactly we don't talk about accuracy much in the context of classification. So I'll see you in the next video. Bye bye, guys. I'm sorry for this long video, really.